Now let us understand how to find domain and range of absolute functions. Just to remind you, absolute functions will look like this, right? Always positive. So that is an absolute function. So you can see domain is all real numbers and range is greater than or equal to 0. It's always positive. Now let's find a domain range of transform functions. So what we see here is that for an absolute function, domain is always real numbers. So without thinking much, we can always write domain is x belongs to real numbers, right? So let me just finish it up here for both of them and write domain is x belongs to real numbers, right? Now let's look into the range. As far as the range is concerned, let's look into what are the vertical transformations. Now here, the vertical translation is it is translated 1 unit up. Since it is translated 1 unit up, now we know instead of y greater than or equal to 0, it should be greater than or equal to 1. And so we get y belongs to real numbers where y is greater than or equal to 1. That's it. So that is how we can find domain and range for this function. Now let's look into the second example. Now this part here is like 4 minus x. Let me rewrite this equation in a different way, which is minus. We can take minus as common. So I can also write this as x minus 4, absolute value, plus 2. Now for some it may be confusing. So let me rewrite this. So we can first write this as 2 minus absolute of, I'm taking minus factored out, right? So we get, when I factor out minus from minus x, I get x minus 4. Do you see that? Now absolute value of negative thing is always positive, correct? So we get x minus 4, right? So we have a translated absolute function, 4 units to right, correct? So it's kind of translated 4 units to the right, horizontally. And this means reflection, that means 2 units up. So let me sketch this function also. So if you sketch it, what you find is that the function, this is our absolute x, right? It gets reflected. So let me reflect this function here like this. Then it gets translated 4 units to the right. Well, that is like this, 4 units to the right and 2 units up. So let's say 2 units up. I'm just drawing a rough diagram, okay? So that's what we get, right? Now in this, if I put x equals to 0, I know this is minus 4 plus 2. You can place it here also. So you get 2 minus 4, which is minus 2. So this point is minus 2. Anyway, important point is this one, the vertex of your absolute function, which is at 2, this 2. And therefore we can write range, range R equals to y belongs to real numbers. Since it is reflected on x-axis, y is less than or equal to 2 units. Do you see that? So from the equation you can always get. The equation says that the function is translated 2 units up and it is reflected. That means the range is not greater than but less than or equal to the value 2 by which it has been translated upwards. So you get your range. So for an absolute function, look into the y transformation. So here critical things to consider is consider vertical reflection and translation. So these are the two things which are going to affect the range for the function. Domain is all real numbers, so don't have to worry much about the inside part of this function. So that's kind of helpful to know. Okay, I hope this will help you to write down domain and range for any absolute function. Thank you and all the best.